Okay, so now we're doing question 7, part A. And that is normalise the following numbers to 8-bit mantissa and 4-bit exponent. Okay, so our number that we are working, our number as source number is, we're going to do 0. It was what? 0.000001 10 and then 0.001. Okay, that's our mantissa and that's our exponent. Okay, so we've got to normalize this and so let's look at this. So this is not normalized, right? So imagine an exam question saying, is this number normalized? It's not normalized. It's not normalized because it's not, doesn't start with 0, 1. It doesn't start with 1, 0, 1.0, or it doesn't start with 0.1. A normalized number must start with either that. And by the way, this is a negative and this is a positive. Right? That tells us this. That tells us whether the binary number, the 2's complement number, if it's negative or positive, right? It's just a trick to tell you that, and something very useful. Okay, so we need to normalize it. So we need to move because it's negative, because this number is actually positive. Okay, because this number is positive, right, the most significant bit of the 2's complement number is positive. So we're dealing with a positive number. That means that we have to move the decimal point, so we end up with this, with a positive number. Okay, so let's move it to that position. 1, 2, 3, 4. That's actually right. Let's do that again. 1, 2, 3, 4. That's where the decimal. That's where the binary point will end up. Okay. Now that was plus 4 jumps. Okay. And this power, this could, hopefully I can explain this, it's probably going to be complicated. This means it's, so to be clear, that's not right, 4 minus 8, because that's 2's complement. So this number is obviously 2 to the power 1, okay? That's what that exponent is representing, that 1 comes from there. Okay, now we're going to I'm going to remember what the question is saying first. Yeah, okay, so this is my method for these questions, right? We are making an adjustment here to normalize it. That's to normalize it. That's what we did there. But it also has a power here for the for its exponent. So we're going to make an adjustment, and this is my way of looking at it. Right, so our adjustment here is going to be 2 to the 1, that's from here, and we're going to multiply it by 2 to the 4, okay? That's what we just did here, right? And using our rules of indices, that's going to be cut to here. Now, that adjustment for normalization, that's going to be actually 2 to the minus 4, because we put that, to normalize it, we put the binary point here, but that's just to represent the number. The actual number, we need to reverse that 4. So that's why when we apply it to this, that's why it's a negative. Okay. Now from our rules of indices, that's going to be 2 to the minus 3. Okay. So now what we're saying is that this number, I'll write it out again, which will be 0.110, is going to have an exponent of minus 3. Okay, that came from there. Okay, and we've got, it's 8-bit mantissa, so we need to fill this in. So that's 4 bits. So 1, 2, 3, 4, 2 nibbles. Okay, right. So that's our mantissa. And our exponent, we need to code minus 3. So what I'm going to do is I'm just going to put 3. I'm going to put 3 in our exponent, and I'm going to 2's complement it, so I'm going to flip it and then add 1. Okay, so that is our number. So the answer is the answer is here for the mantissa, and this is our exponent. Now remember, don't put the answer not in final answer. Okay. Right, and that is our final answer.